Hello, I will present a demonstration on the policy-based orchestration and enforcement across the distributed infra E structure, using the UMU orchestrator in this case. In this scenario, on one hand, we have two nodes, node A and node B. There are no connections present between them, and node A possesses a limited resource. On the other hand, we have an intent policy that requests the deployment of an HTTP server with a hard constraint of CPU greater or equal than 3. The orchestration process is divided into two distinct phases. The first one, select the software candidate for a set of candidate, and the last one, select the node candidate. Once the architecture process ends, the enforcement starts. So we will try to deploy the intent on the node A, but the node A doesn't met with the requirements. So we will try to acquire new resources using the rear manager. This is the policy we'll send using the service handler. Now we have the context of the scenario, we will see the demo. In this window, we see 4 terminals. The terminal at the top left is for control, node A. Currently, there are no peering candidates in the system. The bottom left terminal is also for controlling node A, and it indicates that node A is not composed of any other nodes. The terminal at the bottom right shows node B, where we display the various namespaces that make up node B. In the top right terminal, we have node orchestrator of the node A displaying its logs. Here, we observe node A's flow. Notice, node A has only one CPU. Thus, it doesn't meet the intent's requirement. Looking at the policy, we see it demands deploying an HTTP server with a CPU constraint of at least 3. Now the next step is to send the intent policy through the service handler, since it is the entry point of the system, and the service handler sends it to the node orchestrator, and the node orchestrator will be in charge of translating the policy in order to make it understable for the system. Now, as we have said before, we send the policy using the service handler, and to send it to the node orchestrator in the terminal on the top right, we can see how the node orchestrator has received the policy. And start the orchestration process. In this image, we can see the workflow of the orchestration processor. The first thing it does is to select the orchestration algorithm and the algorithm. On the one hand, select the software to use as HTTP server from a set of software candidates. On the other hand, the node where the software will be deployed from a set of node candidates. But it realizes that the node doesn't meet the requirements of the policy, so it searches for peering candidates in order to address the policy. If we remember, we had no peering candidates. Therefore, the node orchestrator will create an event of type resource acquisition in order to trigger the node orchestrator when there are resources available and a request to the rear manager to obtain resource. Now, in the terminal of the node orchestrator, we can see how the orchestration process select NGINX as HTTP server. And it realizes that there is no node that meet with the requirement of the intent. So try to acquire a new resource, but we don't have peering candidates. So we have to ask to the rear manager in order to acquire new resources. The node B. Now the system throws an exception advising that the intent policy cannot be deployed at the moment, and it has been created an event to deploy when the resources are available. In this window, we can see that event we mentioned before, which is a dependency of type resource acquisition. Now, what will happen is that the real manager will offer node B as a candidate as there is an event of type resource acquisition in the system. As soon as it detects that there are resources available, the orchestrator is triggered and the orchestrator process starts again. But this time, it will be able to deal with the policy. Because we have the resource of the node B. We can see that in the system we have a candidate. If we see in detail the request that the node orchestrator did to the rear manager, we can see that it's asking for a candidate with a minimum CPU of 3. Right now, what is happening in the terminal of the node orchestrator is that it has been triggered because there are resources available, which means that the rear manager has provided us with a valid candidate. The node orchestrator established the peering with the node B, as can be seen in the terminal on the bottom left. Once established, we can see that we have a new node in the cluster. And if we go back to the terminal of the node orchestrator, we can see how the orchestration process starts, which this time will select the node B as a candidate, and it will be able to meet with the requirement of the policy. B. Within it, there's an HTTP server as the policy required, and it's an NGINX as chosen by the node orchestrator. Checking node A's terminal, the namespace details show NGINX is deployed in node B. Thus, the policy previously undeployable is now successfully deployed on node B. If we see the window of the flavors, we can see that we have a new flavor on the system, which is the node B. At this point, we can say that the workflow of this demo has been complete. Thank you so much.